This is one of my favorite labs, and I've been doing this one for 20-something years. And if we want to measure the initial velocity of something going straight up in the air, it's going to be difficult for us as a human to throw it up exactly the same speed each time. So that's why we use this Playskool Launcher, which these are made for little plastic baseballs, and we're going to do 10 trials. So in this experiment, we will determine the initial velocity of a ball as it leaves a launcher. And we have other brands now because they don't really make these anymore, so there's a variety of different ones. The launcher will release the ball with the same initial velocity in order for us to make correct calculations. In this chapter, we're studying motion in one dimension. So we'll use our straight line motion equations to determine the initial velocity while taking the measurements. So we have our launcher. We're going to have a plastic ball. We're going to have, you might need 2 meter sticks and then a stopwatch. So you're going to place the ball in the launcher, and what I would do is I would place 2 meter sticks like on top of each other and try it out, because some of them go really high, so you might have to put it on the floor and then press it with your foot. You're probably better off doing that so you can measure it. Now the thing is, if you look at this diagram, when the ball is down before it launches, it's probably around here. It's not on the ground. So then if the ball goes up to here, this is the vertical displacement. Now all you're going to do is measure the time it takes to go up. You're not going to do up and down. You're just going to measure up in a straight line. So here the initial velocity is a maximum. Then when it gets to the maximum height, you know the velocity is 0. So you have to, with the ruler, measure from the ground, and let's say this is like 10 centimeters. You can't really hold the meter stick 10 centimeters above the ground. So just go ahead and rest the meter stick on the ground, and then remember at the end to subtract 10 centimeters from whatever value the maximum height is. And again, you might have to stack 2 meter sticks on top of each other. Now, of course, this is moving in the air, the ball, so you're not going to get an exact measurement. You're not going to measure to 2 significant figures. You're not going to measure to 100th of a centimeter because you can't see that. So just approximate your answers to the nearest whole centimeter. So you're going to repeat this step where you're pressing it down 10 times, and be ready. Don't just keep doing it, because I really wouldn't appreciate it if you break my launchers. And again, you're going to measure the maximum height. While this is doing this, remember, in order for a lab to be successful, you have to work efficiently and effectively. And that means everybody in the group is doing something. So one person will be stepping this down, one person's going to be holding the meter sticks, one person's going to be measuring how high this goes, and then another person's going to be using the stopwatch, and the person with the stopwatch is going to see how long it takes to go from here to here. So when you look at your chart, you see here's my launches, here's my maximum height in centimeters, my time in seconds, and then you're going to average it. Remember, in class, you're just taking your data, and then you do your calculations at home for homework, because you have to get your data done in class. Then on the back, we're going to practice using all the equations that are going to be on our test. So first of all, it says for all the problems, write your given, show all your work, write your basic equation, rearrange your equation to solve for your unknown in terms of your known, include your units, and box your final answers. So here it says calculate the maximum height, and then calculate the average time. So that's what you're going to do on the front, but you need to show your work. And don't forget to show your equation. How do you calculate average? Now we're going to use physics. So it says when the ball reaches the maximum height, the velocity is 0. Use the information from the chart for average time, this equation, and the acceleration due to gravity to calculate the ball. So you're going to write your given, your find, basic equation, substitute, and solve. Then you're going to do this equation, then you're going to do percent error, and then you're going to answer these questions. And that's it. Now hopefully you'll get this done in class and you won't have to do this for homework, because this is a pretty easy lab. If you just don't play around, you get your data, and then you can do all this.